Hello. Chat. Okay. Um, so um, today's reading was about Hume's theory of space and time in the treatise. Before I start discussing it, I just want to remind you that this may be stuff that Hume changed his mind about later. In fact, from some of the brief things he says about it in the Enquiry, I feel like he is going in a somewhat different direction there, but I'm not aware of a place where he developed a complete different system later. Maybe there is a place that I'm not aware of. Anyway, um, this system that he develops in the treatise is very interesting and weird, so that's what I'm going to talk about. And it has two parts. Um, Identified by Hume himself as the two parts of his system. So one is composition of extension out of finitely many indivisible parts. And the second part is that each part must be of some quality. In particular, it must have color or solidity. Um, I'm not sure why heat and cold are not allowed here, but anyway, they're not. Um, so, in a way, neither of these two parts is a surprise in the sense that uh, Berkeley certainly agrees with both of these parts. I mean, right? We know he agrees with this part that uh, any extended thing is composed of a finite number of indivisible parts, so it can't be infinitely divided. Um, and the other part, uh, well, for Berkeley, that divides into two things, right? But visible extension can be divided into visible, indivisible parts, and each one of them must have a color, because remember, Berkeley thinks we can't abstract color from extension. Um, and tangible extension must be divided into parts which have solidity. Um, Again, or you might think you could have heat and cold, but apparently not. All right. So, but these come out much um, more interesting and weirder, I think, in Hume's treatment because, and this is something you have to keep in mind to understand this whole section, right? This is Treatise Book 1, Part 2, on the ideas of time and space. To understand this whole section, you have to realize that it's written from the point of view that external objects exist and they're represented by our ideas. right? So, of course, Berkeley never allows that. So when Berkeley says um, that things are composed of a finite number of indivisible parts, and if you ask him, well, do you mean our ideas of things, or do you mean the things themselves are divided into those parts? And he'll say, well, that's the same, right? Things are our ideas of things. Um, but Hume, um, in this whole section, talks and thinks as if it's perfectly clear and makes perfect sense to think that there are things and then there are ideas that represent them. Um, Now, as we'll see coming up in the treatise, there's a very strong skeptical argument against that, right? I mean, he doesn't claim to prove that it's absurd the way Berkeley does, but he does, well, yeah, maybe I shouldn't say that. He doesn't claim to prove the way Berkeley does that the very idea of an external thing or a mind-independent thing is absurd. Um, he does in part four um, seem to show that the philosophical version of that, where um, um, what exists externally to us is represented by our ideas, and there's no overlap between our ideas and those external things. Uh, he does claim to show that at least the main versions of that he knows of are actually absurd. Um, but uh, but he also says there that the common sense view that isn't absurd nevertheless involves us. Um, okay, actually, maybe let me put off trying to sort out exactly what he says until we actually talk about part four. The point is, in part four, there's going to be a strong skeptical argument against the idea of external things. But he also says in part four that the conclusion of that argument is not convincing. We can't believe it. So as soon as we stop thinking about it, we'll go back to believing in external things. Um, it's quite consistent for him here in this section, which is about the ideas of time and space, not to try to suspend belief in external things, which he thinks we can't really do, but to take for granted that there are external things and they're different from our ideas, but our ideas represent them. So that's one thing you need to understand how Hume understands these 2 points. But the other thing you need to understand is how literally he takes the view that our ideas represent by resembling their objects. I mean, for one thing, he says, or really takes for granted, that our ideas represent objects as being of some size by being of that size. Right? So I represent an object as large by having a big idea. um, and this applies to visible and tangible ideas because those are the only ideas whose objects are extended, according to Hume. Because those are the only ideas that are extended. So, now, that much, as you may recall, Locke seems to endorse. And I mean, of course, Berkeley agrees with it, since there isn't anything, according to him, that could be large or small except an idea. But it is kind of weird. That's what he assumes. But moreover, he also assumes that our ideas represent objects as being colored or solid because the ideas themselves are colored or solid. So I represent um, an object as red by having an idea that's red. In other words, he takes for granted, or I mean, he has an argument for it elsewhere, but here he just takes for granted that the external things that are represented by our ideas are not a different kind of thing from the ideas. They're just external, right? So, like, if there's a thing out here that's red, um, and here's my idea that represents it. So, like, the idea is the kind of thing that could be out here, right? It's not, and this is almost the opposite of Berkeley, right? It's not the kind of thing that can only exist in a mind. It could exist out there. This one's in here, and I use this one that's in here to represent this one that's out there. That's the view of representation that he, again, is not arguing for in this section, but taking for granted. Okay, so that's most of what you need to understand, or to realize to understand his argument in this section. But I think there's one other thing, which is that the only strict sense in which one thing can be larger than another is to contain more parts. Right? So, in other words, it's basically numbers that are larger or smaller than each other. And when we say that something else that's not a number is large or small, we're counting its parts. We're using numbers to count it. Now, I mean, in a way that makes sense. Larger and smaller are matters of quantity. And how do we measure quantity? By counting it, right? So, but what he's saying is, like, that's the only thing, strictly speaking, you could mean by saying that one thing is larger than another. Now, I mean, comparing this to Locke, um, it seems to follow from Locke's view of how we form ideas of quantity, right? Remember that according to Locke, ideas of quantity are simple modes, and at least certainly in the case of numbers, he explains that we get simple modes by repeating the idea of an unit over and over again, right? So the idea of 2 consists of the idea of an unit added, repeated twice in one complex idea. And it at least sounds like he's saying something similar about space and time, in which case, again, he would have to think that the idea of an inch is the idea of a unit of space repeated a certain number of times. And that you get a bigger quantity of space by repeating the idea of a unit of space more times. Now, when we read that section in Locke, I argued basically that Locke couldn't mean that. That he must mean something a little bit different. And essentially, my arguments to the effect that Locke couldn't mean that are the same as Hume's arguments here, right? That is, I said that if Locke meant that, he would have to believe that extension is finitely divisible into indivisible parts, which he doesn't. So, but in any case, it does sound like Locke means that. It's like hard to figure out what else he might mean. So it's not, from that point of view, that unreasonable for Hume to assume this. Okay, but the consequence of that is, if it's really true that for A to be larger than B, in a strict sense, just means that A has more parts than B. And if some of our ideas are indivisible, right? So suppose I have an idea that can't be divided into smaller ideas. Then it follows that, strictly speaking, nothing could be smaller than that idea, because nothing has less than one part. Right? So a question that at first you might think didn't make sense at all, Hume gives a really definite answer to, right? So like, here's the question, here's my tiny indivisible idea. This is the mind. And here's something out here. And the question is, which is bigger, my idea or the thing? Right? Like maybe this thing is a grain of sand. And I ask, which is bigger, this indivisible idea in my mind or this grain of sand? And again, you might think that question doesn't make sense. How can you compare the size of an idea to the size of a grain of sand? But Hume says, well, this only has one part. This has at least one part, because if it had 0 parts, it wouldn't be there. This has at least one part, so this can't be smaller than that. QED. Right? And moreover, if I believe that this has more than one part, right? Like, even if I can't see the parts, if I believe that it can be divided into smaller parts, then I believe this is bigger than this, because this has more than one part and this doesn't. So now, and at this point, I'm basically summarizing the whole argument for this first part. I hope to have time to come back later and talk about each of the steps in more detail, but in case I don't, I'm going to pretty much finish summarizing it almost right away. So the conclusion of this is that although there may be things that are too small to see, there can't be things that are too small to imagine. Right? So, suppose a 1,000th part of a grain of sand is too small for me to see. So I crush the grain of sand up into tiny pieces, and I can't see the pieces anymore. But suppose they're still there. Okay, fine, they're too small to see. Meaning, they're too small to cause an impression in me. But they're not smaller than this indivisible idea. They can't be smaller. So if I represent them by this indivisible idea, I can't be imagining them as bigger than they are. Imagine them as smaller than they really are. So make them smaller and smaller and smaller until they get to be this size. Now, if I represent them with this indivisible idea, I'm representing them as exactly the same size they are. I'm imagining them as the size they actually are, because I'm representing them by an idea, right? If we now imagine we have an indivisible part of this grain of sand, So this has one part, this has one part. They're exactly the same size. So as I use this one to stand for this one, I'm imagining it exactly right. And there can't be anything smaller than this. So as I said to begin with, although there can be things that are too small to see, there can't be things that are too small to imagine. The smallest possible thing would be exactly the same size as the idea I would use to represent it, not smaller. Um, so, in other words, Hume is going to say that the limitation of our senses, the mistake it leads us to make, is not that it prevents us from representing things smaller than a certain size, which is the way Locke and even Berkeley weirdly think about it. Right? So, like Berkeley says, there is no such thing as the 10,000th part of an inch, meaning that, like, the limits of our ability to see parts place a lower limit on how big a thing can be. I mean, I say weirdly, that Berkeley has no option because he doesn't have this distinction that Hume is working with between ideas and their external objects. But in any case, so what Hume is saying is that the limitation isn't that it prevents us from representing things that are smaller than a certain size, but rather it causes us to represent things as smaller than they actually are. Right, so here we're talking about an idea, but let's talk about the grain of sand causing an impression in my mind. So, suppose the grain of sand is so small that if it were any smaller, I couldn't see it. Now that's actually kind of a weird thing. Like, as Hume himself knows, there isn't actually a point where something is exactly that small and then the next second it disappears. It gets like harder to see or something, and it kind of, but or at least it isn't clear where that limit is. It's hard for us to fix it. But I guess Hume thinks that although it's hard for us to focus on it, there must be some limit. I mean, at every time we either can see it or we can't. There's nothing in between. So there must be some last point. This has to do with the way Hume thinks of orders and their limits in general, and it comes up in other places in this section too, I think. But so there must be some last place or limit, the last time you can see it. And that's when it says, the last time you can see the grain of sand, right? So as you make it smaller and smaller, at some point you can still see it, and then the next time you make it smaller, you can't see it. So at that last instant when you can still see it, how big is the impression? The answer is, according to Hume, the impression is as small as an impression can be, a visible impression in this case. It's as small as a visible impression can be. That is, it's indivisible. So I'm representing this grain of sand by the smallest possible idea. But supposing, that the grain of sand, and I mean, in this case, we could say we know this is true because I've seen the grain of sand from closer. And when I saw it closer, I could distinguish different parts in it. The same grain of sand, when I move it closer, now I don't represent it by an indivisible idea, but by a slightly bigger idea. that has parts. So I know the grain of sand actually has some parts. Therefore, I know the grain of sand is actually bigger than this. And so the thing, again, that my vision is doing, the way it's limiting me, is it's making it difficult. It's making me represent things as smaller than they really are. And if, the grain, if we know because we not only have seen it closer, but we used a microscope and whatever, that the grain of sand actually has millions and millions of parts, then that means that the grain of sand is much, much bigger than it looks. That's the way Hume understands what's going on there. And again, you might think, wait, this doesn't make sense. What do you mean it's much bigger than it looks? Like, how do you compare how big it is to how big it looks? But again, the answer is you compare by counting parts. The way it looks only has one part, that is the idea, and the grain of sand itself has a million parts, so the grain of sand is a million times bigger than the idea. It's a million times bigger than it looks to me. If I wanted to imagine the grain of sand accurately, that is represented by an idea that is as big as it really is. In that case, actually, my problem would be that it's too big for me to imagine. Right? It has a million parts. I would have to imagine all million parts. So although there are no things that are too small to imagine, actually almost everything is too big to imagine accurately. Okay, are there questions about this part so far? I mean, I think you really have to focus on it because in some ways it's kind of like the opposite of what you usually think or something like that. And, but it makes sense, at least, I mean, it's a little strange, and that's why you have to then go back and stop at all these assumptions and be like, well, is that really true? Is that really the only, but I mean, it's like, it's consistently developed, put it that way. Okay, so now, I mean, I haven't quite finished. I said I was going to summarize the whole argument. I haven't quite finished summarizing. Like, so far, we've shown that there are, well, we haven't shown. I've taken for granted, Hume does claim to show that there are indivisible ideas, that the idea of extension is not infinitely divisible. Then the question is, how do we know that external things are not also infinitely divisible? I'm sorry, that external things are not infinitely divisible. That is, how do we know they're not infinitely bigger than they look? They always look like they have a finite number of parts because every one of our impressions or ideas has a finite number of parts. But maybe they really have an infinite number of parts. So, I mean, Hume has a number of arguments to try to show that they don't. But I guess the basic one is this, that we know every time we add together our ideas of extension, we always get a bigger extension. So we know if we could keep doing that forever, we would get an infinite extension. That's possibly a little bit questionable, but anyway, you can see why you would think that, right? I mean, like, I guess, I mean, that is, you might think, well, maybe you add these parts together and each one is smaller than the last, and so you never get to an infinite extension, but they're all exactly the same size 1, right? So nothing like that can happen. So, I mean, you can say every time you add one of them to another one, the resulting idea is always the same amount bigger. So it keeps getting bigger at the same rate, namely 1 per 1. As long as you keep adding one. And if you kept doing it forever, it would be infinitely large. And so he says, so we know that when you add an infinite number of finite things together, you get something that's infinitely large. Because again, like these things represent things being bigger and smaller and having parts and etc. just by having those properties themselves. They aren't a different kind of thing here, right? So in other words, for this grain of sand to be infinitely bigger than it looks, it would have to be infinitely big. And then Hume uses a type of argument that Berkeley used too, and that's, I mean, has its roots in Aristotle, which seems wrong to us, at least if we've been trained in modern mathematics, but is actually like, it's not clear whether we've kind of learned that this was wrong or just got used to denying it. But in any case, he says, well, look, if it's infinitely large, then by definition it has no end. So it can't have a size or shape. But like all the things that we see evidently have some determinate size and shape, right? Like it goes to here and then it stops and it's not there anymore. So no matter how big it is, it can't be infinite. So we couldn't possibly represent things as being infinitely smaller than they are. Therefore, this is finitely many times bigger than its idea, and so it has a finite number of parts. And meaning of indivisible parts, right? Because if the parts are divisible, then that should mean you have more parts. If they're all divisible, then there's infinitely many parts. So it must have a finite number of indivisible parts. Okay, other questions about that type part of the argument? Because, so notice, I mean, it's more complicated than Berkeley's argument. Berkeley just says all our ideas are finitely large, contain finitely many parts, and ideas are all there are, so everything contains finitely many parts. Everything extended, that is. But Hume makes, allows this distinction between ideas and things, causing a much greater difficulty for himself, right? That is, if he just denied the existence of external things, all he would have to show is that we have indivisible ideas and he would be done. But now he has to show that from the fact that we have indivisible ideas, it follows that there are indivisible parts of colored and solid things. And to do that, he needs this extra step of why they couldn't be infinite. Okay, so I'm about to go on and talk about this part, but before I do that, I just want to note a consequence of this, which is, well, it's kind of two consequences, but so like one consequence is for any given two things, one of them actually is either larger or smaller or exactly equal to the other. Right? Because each one of them contains some finite number of parts. And those two numbers either have to be equal or one is greater than the other. So that's one thing. I mean, that's not so weird. But the weird part, I mean, even this, it's still not so weird. It's just what this ends up meaning that's weird. In general, we can't tell which, right? That is, in general, we can't count all the parts to tell which one is bigger than the other. And moreover, even with respect to our ideas, so, right, I mean, with the external things, we can't count the parts because in general, we can't see the parts or feel the parts. They're too small. But of course, in the case of our ideas, we, every part of the idea is part of my idea. So I'm imagining every single part. But Hume says it's still, when the imagination is at its limit that way, it's like weak and confused, and it's hard to focus and count exactly how many of those indivisible parts there are. Right? So, like, if you try to imagine a point getting smaller and smaller until it's the smallest you can imagine, and then try to add another point just as small to it and put them right next to each other and imagine how big that is. Well, I mean, so the best you can say for it is that it's very difficult to focus on. Right? I mean, whether that corresponds to anything we really do is another question, I think. But Hume, again, I think for a similar type of argument, I mean, that is as hard as it is to focus on or remember, it must be possible to do that because, I mean, either there's one point or there's two. There's nothing in between. But it's hard to do, and therefore, even in our imagination, we don't, in general, compare things to tell which one is bigger than the other by actually counting the parts. So what do we do instead? Well, now I'm going to switch to the document camera, and I have to tell you, unfortunately, I think my copy, or I think I actually have more than one copy of the edition I ordered, but I think they're all in my office in Santa Cruz. So I've gone back to a different edition that I had here, but I'm going to tell you the page numbers in the one that, I don't know if it's the one you have, but anyway, the one I ordered for the course. So this, it's actually a passage that Hume instructed to add in his appendix to the first edition. So in this book that I have here, they printed it in the back in the appendix, but in your book they inserted it where he wanted it to be, and it's on page 36. So it's book 1, part 2, section 4, paragraph 22. To this reasoning, I entirely agree. Well, maybe I should read what the reasoning is. Is that text readable? It looks kind of blurry or something. I don't know. Oh yeah, there you go. There are many philosophers who refuse to assign any standard of equality, but assert that 'tis sufficient to present two objects that are equal in order to give us a just notion of this proportion. All definitions, say they, are fruitless without the perception of such objects, and where we perceive such objects, we no longer stand in need of any definition. Now you expect Hume to say, no, we have a definition of larger and smaller and equal. It's larger if it has more parts, it's smaller if it has less parts, and it's equal if it has the same number of parts. But instead he says, to this reasoning I entirely agree, and assert that the only useful notion of equality or inequality is derived from the whole united appearance and the comparison of particular objects. So what he's saying here is that Um, although there is this strict standard of equality and inequality, which derives from counting the parts, in practice we can't use that, or at least almost never can use it. And so how is it that we go around calling some things bigger than others and smaller than others, etc.? Well, he says it's not really that strict standard. It's an overall impression we get from looking at two things. And if you ask what overall impression, he says, along with those philosophers he was just quoting, there's no point in defining it, but you'll know it if I show it to you, right? So if I show you a small thing and a bigger thing, you just look at them and there's a difference between them, which you express by saying that this one is bigger. You don't do it by counting the parts, you just see it. So the first one that's derived from counting the parts, he calls the just notion of equality, or the strict notion of equality. But the other kind, he calls the loose notion, the looser notion. And according to the looser notion, it's no longer true that for any given two things, either one is larger than the other or they're equal. Rather, sometimes one of them is evidently larger than the other. Sometimes they look equal, and sometimes you can't tell. Right? So that's why it's a looser standard. And also another thing about the looser standard, the strict standard, if you count correctly, you can't get wrong. Right? If you count the number of parts in this thing and there's 5, and you count the number of parts in this thing and it's 3, then the first one was definitely bigger. But by the loose standard, something can look bigger than something else. But later we have ways of correcting it by which we say, oh, it looked bigger, but it wasn't really bigger. So what those ways of correcting are, maybe I'll talk about in more detail later, but that distinction could be important to keep in mind because some of Hume's conclusions that are based on the strict standard may not really turn out to mean what you would think if you remember that what we actually use is the loose standard. Okay, so that's my summary of the argument for part 1, namely the composition of extension out of finitely many indivisible parts. Now I'm going to discuss Hume's argument for part 2. Each part must be of some quality. That is, each one of these indivisible parts must have a certain quality, and that quality must be either a color or solidity. If it's a part of visible extension, then it's a color, and if it's a part of tangible extension, then it's solidity. So this means there can't be a part of extension that lacks a quality. And therefore, there can't be an entire extension that lacks quality, right? I mean, it might not have a uniform quality, but every extension is composed of parts that have these qualities. So every extension is everywhere colored or everywhere solid, depending whether it's visible or tangible. And therefore, it follows, as Hume says, that a vacuum is impossible. Right, so going back to this, this is on page 40 in your edition, and it's part 2, section 5, paragraph 1. If the second part of my system be true, that the idea of space or extension is nothing but the idea of visible or tangible points distributed in a certain order, it follows that we can form no idea of a vacuum or space where there is nothing visible or tangible. Okay, so in saying that, he's taking a side in a big argument that's been going on, well, since antiquity, really. Right? The ancient atomists maintained that everything was composed of uh, solid atoms moving in a vacuum. Aristotle came to prove that a vacuum is impossible. So Aristotelians basically believe that a vacuum is impossible, at least in some sense of the word impossible. Uh, um, and Then in the early modern period, this argument was taken up again. Descartes claiming to show that a vacuum is impossible in a much stronger sense than Aristotle argues it, I think. Um, Basically because, or another way of putting it is that Descartes thinks there is only vacuum, that body is not different from vacuum, right? Because Descartes doesn't think that solidity is a real property of bodies. He thinks only size, figure, motion, and number are properties of corporeal substances, not solidity. So he thinks there would be no difference between a body and a vacuum, or to put it another way, everywhere there's extension, there's a body. Now, and as you may recall from Locke, Locke argues the other point of view and says that number one, a vacuum is certainly conceivable, and then moreover, he claims to prove there must be a vacuum because he says if there were no vacuum anywhere, there couldn't be motion. Because a body can't move into a space where there's already another body. So if everything's all full, nothing can move. There must be at least one tiny little space. All we need is one tiny little space, and then everything can move. But there must be at least one. So that's the argument that Hume is entering into here. And it's particularly interesting also because it seems to involve the confrontation between Newtonian physics and the Cartesian / Leibnizian physics. I mean, they disagree about a lot of things, but they agree about this, that space is full, that it's a plenum, which is the opposite of vacuum, right? Vacuum just means it's empty, plenum means it's full. So Descartes and Leibniz agree that space is a plenum. Newton, on the other hand, in order to derive the motions of the planets, has to assume that they're moving through a vacuum. And it sounds like Hume is coming down on the no vacuum side. So he sounds like he's coming down agreeing with Descartes and Leibniz that space is a plenum. However, it turns out that when you understand what Hume means by this, and is this important? I guess, I don't know. I just love it because it's so clever, if nothing else. It turns out that when you pay attention to what Hume means by this, it's actually a much closer to what most people mean when they say there is a vacuum than it is to what most people mean when they say there is not a vacuum, that is, there is a plenum. And in particular, Hume agrees, so maybe I should erase these two parts. So Hume agrees that matter between two surfaces that all the matter between two surfaces could be annihilated. Without anything moving and without the surfaces touching. Afterwards. Right? So, like, suppose you have a room that's full of air. Air is, I guess, not visible, but it's tangible. You can feel it if you move your hand through it. So, suppose you have a room full of air. Hume agrees that the air could be annihilated. And when I say this could happen, it means we have an idea of it. It's conceivable, right? So we can form an idea of the air being annihilated and the walls and ceiling and floor of the room not moving. And afterwards, the walls don't touch each other, the ceiling and floor don't touch each other. Right? This is something that Descartes, for example, would say is impossible. And because Descartes doesn't want to deny that God could annihilate a body without affecting the surrounding bodies, he concludes that if God did annihilate the air in the room, the surfaces that were separated by the air would now touch each other. Of course, that's hard to understand, as Hume points out. Wait a minute, how can the ceiling and floor touch each other while the walls didn't move and they're still, whatever. I mean, how Descartes thinks of that, I'm not sure. He probably thinks that it would just be very strange and it could only happen by a miracle. And that's probably the best you can say about it from his point of view. But I think it's easy to predict what empiricists will say about that. Well, that just doesn't make any sense. We have no idea of that. It's just gobbledygook. So, but of course, someone. Could address this by saying, and I mean, this is what Spinoza says, essentially. If you ask Spinoza, what would happen if God annihilated the body that's between these surfaces? Spinoza would say, everything that exists follows necessarily from the nature of God. The air between these surfaces is a mode of the divine attribute of extension. God can't annihilate it. That doesn't make sense, right? So he would deny this part. And although I don't know anyone who holds this view, I guess you could imagine someone saying God could annihilate it, but only by smushing the room, right? So that would mean that things would have to move. So God could annihilate the body, but he would have to do it slowly and make the room smaller and smush it as he did it, or something like that. So, but Hume says, no, we can have all these things annihilated, the sides don't move, and nothing touches each other afterwards that didn't touch each other before. So that sounds like the air has been annihilated and there's nothing left where it was. Isn't that a vacuum? This is, if you want to see, I don't think I'm going to read this from the text, but if you want to see where he says this is book 1. Everything's book 1, part 2 today. Well, actually, with one exception, I'm going to read from part 4. Maybe I should keep saying it. Book 1, Part 2, Section 5, paragraph 23 on page 45 is where Hume concedes that this is possible. And by the way, I mean, remember, for Hume, if something is possible, that is, we can form an idea of it, and then someone says, but it never actually happens, that could only be based on experience, right? There's no contradiction in it. So the only way we can tell if it ever happens or not is by experience. Maybe it happens. But okay, but Hume also agrees that a body can move indefinitely far without encountering resistance. And without displacing any other body. Right? So a body can start moving and just keep moving and moving and moving and getting farther and farther away from where it started. And I'm emphasizing that getting farther and farther away from its started part because, like, Descartes at least thinks that he can explain how motion is possible in a plenum. Actually, Aristotle already says this in his argument against Parmenides, but that he can explain how motion is possible in a plenum by saying, well, circular motion is possible because, as this moves out of its way, this moves out of its way, they all move together, and so there doesn't have to be any spaces. I guess Locke is not convinced by that. But anyway, if you, I probably already said this in this class, that if you look in the later parts of the principles of Descartes' Principles of Philosophy, the part people don't usually read, you'll find they're like full of diagrams like this, of stuff going around, like particles going around in circles. But no, here we're talking about a body moving indefinitely far from where it started, so it's not going in a circle. And it never encounters any resistance. And it never has to move any other body out of its way. So, Hume says this in the next paragraph after the one I just cited. Book 1, Part 2, Section 5, paragraph 24 on page 46. Basically, by conceding these two things, like, for example, as far as the physical argument goes, he's given away everything the quote-unquote other side wants, except now we can see that he really is, they're not the other side, he's on their side, right? That is, if Newton has to assume that bodies can move through the solar system without encountering resistance, Hume is like, yeah, bodies can move as far as they want without encountering resistance. Or if Boyle or someone else has to assume that you could actually create a vacuum using a pump by getting all the air out of a cylinder, Hume is like, yep, in fact, in principle, it'd be possible for that air to just disappear and leave the cylinder empty. So what is it that he's denying here? Well, what he's denying is that we can form the idea of a vacuum. Now, you might say, well, but look, we just said that a vacuum, I mean, it just sounds like we just said that a vacuum is possible. And Hume thinks if something is possible, we can form an idea of it, and vice versa. So if a vacuum is possible, doesn't that mean that the idea of a vacuum is possible? And the answer is um, uh, that when we form ideas of these situations, there's nothing in there that's the idea of a vacuum. Rather, there's the absence of the idea of matter. Oh, okay. Sorry, can people read this now? Someone said they couldn't read it. But the camera does seem to be a little out of focus now. Let's see if I can fix that. Oh, there you go. That's a little bit better. All right. I'm sorry, this I can't find the blue marker I was using before. This brown marker is not as legible, I fear. Right? So, in other words, Hume claims, let's take a simpler case than the room with air in it and so forth. You know, imagine that there's two bodies, and in between them is this other body. Two visible bodies, and in between them is this other visible body, and I'm looking at them. Here's my eyeball. I'm looking at this whole scene. Now, Hume says, I can imagine this visible body being annihilated while these stay just where they are and they don't touch afterwards. I mean, he actually in one point says, well, it depends what you mean by touch. But I think it's pretty clear that according to what we usually mean by touch, we should say they don't touch afterwards. So, because this is what we imagine happening. This one is gone. So I guess maybe I should say I'm actually looking at this. Now I'm imagining this. I'm imagining going from this situation where this one is there to this situation where the one in between is not there. And Hume says, what's between these two ideas in this new complex idea? Nothing. There is no idea here. There's the absence of an idea. There's the absence of an idea of color. So, I mean, at first you may think this is just verbal, right? Like, what difference does it make if I call this an idea or the absence of an idea? But it's actually makes a big difference to you because since this is a real idea, it must either be simple or be composed of parts that have some quality. And that's basically the way he's going to prove this. Right? That is, that's the way he's going to prove the second part of his system. But there's nothing here, and it has no parts. Because nothing has no parts. So then you might start to say, well, what do you mean then when you say that these things haven't changed when this disappeared? Like, weren't these things related to each other by the fact that there were these parts in between? And now that you've taken it away, their relation to each other has changed. In fact, won't it be like Descartes? They touch now. There's nothing in between anymore. So Hume just denies that. He says, um, when we see two luminous points against a dark background, all we see is the two luminous points. Everything that is contained in that impression about their relationship to each other is contained in our impression of those 2 points, not our lack of impression of the darkness. So, right? So, in other words, the way we see these as in a certain relation to each other in visible space is not by adding up what's in between them, but we just see it again like on a single whole view. That's our impression of the 2 points. They're separated by this angle. And that impression doesn't change when this thing goes away. Um, and um, so Hume says, we find by experience that these two situations, so I can imagine this and then I can imagine that. I imagine these two things in a certain disposition with respect to each other with a certain body in between. And I imagine them in that certain disposition with nothing in between. But Hume says we find by experience that if you see this situation, it's possible to get to this one. That is, there's some body that you can move in between here without moving either of these. To say move in between is a little bit, remember, there's nothing here. It doesn't have parts. It is, we can't look to see how big the empty space is, because in the empty space we see nothing. In fact, Hume says that when we see complete darkness, that's the same thing a blind person sees. We're not seeing at all. There's no impression. So, but what we do see is these in a certain relationship to each other. He's saying we learn from experience that when we see this later, we may see these two things still in that relationship to each other with a body in between them. And we learn that this body has to be of a certain size if they're going to be in that relation to each other. And that all the bodies of that size can get in there such that there's no longer any empty space and nothing has to move to let them in. And all bodies that are not that size are either too big or too small. So that's like, it wouldn't necessarily be the case. It could be that when we see two things in this relationship to each other, there could be nothing in between, or there could be any number of different things in between. Right? Hume is saying we only learn that from experience. It's a weird thing to say, but I think that's what he's saying. So that way, by experience, we build up this equivalence between real extension, which consists in having a certain number of parts, and this imaginary or fictitious extension, which consists in having bodies with we don't see anything between, but in such a relation as we know from experience a body with that number of parts could go into. um, okay, but now notice, I mean, I probably don't have time to try to follow up any consequences of this, but I want to point it out because it shows, as I said before, that things may not, some of Hume's conclusions may not mean exactly what they seem to. So, the proof that extension consisted of indivisible parts applies to this kind of real extension. It doesn't apply to this kind of fictitious extension. It doesn't have parts, right? In fact, Hume says, this is Book 1, Part 2, Section 5, Chapter 11, and it's on, paragraph 11, and it's on page 42 in the official class edition. And he says that the distance between these remote visible bodies, he says, is nothing but darkness or the negation of light, without parts, without composition, invariable and indivisible. Right? So the point is, I didn't even draw this right, really. Like, it's impossible to draw it right. But what Hume is saying is that when there's nothing in between the two bodies, sorry, let me switch back to this. When there's nothing in between the two bodies, there's no difference between one nothing and another nothing. There's a difference in the relation I see between the two luminous bodies. But as far as the darkness goes, it's always just nothing. It's always the same. So, strictly speaking, they aren't bigger or smaller amounts of nothing. That doesn't make sense. There isn't a bigger or smaller empty space between the bodies. What there is a relation between the bodies such that a bigger or smaller body can be stuck in between them. But okay, you might think, so sure enough, this argument that extension is composed of a finite number of indivisible parts doesn't apply directly to this nothing, which doesn't have parts. But by that correspondence we learn to form by experience, where we regard this nothing as equivalent to a body of this size, because we know by the relation of these bodies that a body of this size can go into it. And this has to have a definite number of indivisible parts. So we associate this situation with some finite number of indivisible parts. And so, like, through this correspondence, we can talk about each of these imaginary negative extensions as also having a certain number of parts. That's what you might think, except when you think about how Hume describes how we learn about this situation, you realize he's not talking about the just standard, he's talking about the loose standard. Right? That is, of course, we don't learn by experience that if you count up the tiny indivisible parts of this body that went in here, and then you have another body and it also goes in there, and you count up its tiny indivisible parts, you'll find that it has the exact same number of indivisible parts. because we don't do that and we can't do that, according to Hume. Rather, you just mean that according to the loose standard, on the whole, they look equal. Or at least one of them isn't clearly bigger than the other. So this negative extension, there's a correspondence between it and the loose standard, but there's no direct correspondence between it and the strict standard. Which means that Hume doesn't really have an argument that this kind of negative extension is finitely divisible or has indivisible quasi-individual parts. Okay, at least not so far as I can see. Are there questions about that? As usual, I can only say I sure wish there were some questions. At the beginning of the course, there were more questions. But I don't know, maybe people are getting tired. Okay. So I want, like I said, to go back and look at some details of these arguments. There obviously won't be too much time for that, but I still hope to do it. But before I do that, I wanted to say something about the consequences of this view for mathematics. I mean, I said something about the consequences of this view for physics, which the consequences for physics are basically not much, right? I mean, because we agree that things have parts much, much smaller than we can see. Much, much, much smaller, maybe. So are they infinitely smaller than, what difference does it make for physics? We never measure infinitesimal differences either, right? We always only measure some finite difference. I mean, like Berkeley's view is going to cause trouble for mathematical physics, because if there's no such thing as a 10,000th part of an inch, then, I mean, that's a big enough deviation that's going to cause us trouble. But Hume's view, where we say, well, somewhere there's some indivisible part, okay, it's undetectable, let's say. But what about mathematics? Because, I mean, mathematics, of course, claims to demonstrate things precisely. And as I pointed out before, you can prove if this is a square and this is diagonal, you can prove that, however, that if the side of the square consists of some definite number of indivisible parts, and they add up exactly to the side of the square, then there's no number of those same parts that would add up to the length of the diagonal. And it's not like you can prove that, you just wouldn't notice or something, right? I mean, you can prove this by contradiction, right? That is, assume there is such a number, blah, 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 contradiction. So it was absurd, it couldn't have been true. It's not just like you might not have noticed it or something. So it seems like there's going to be a problem for mathematics. So what Hume says is, I mean, he first says, maybe it's not worth going into this in too much detail, because, I mean, he says that the definitions that mathematicians start out with presuppose his view, although all mathematicians think his view is false, right? And that's because, for example, they define a line as something that has length but no breadth. So, I mean, and Hume says, if something has length but no breadth, but it's not nothing, then that must mean that it has no breadth in the sense that it's indivisible in this direction. You can't make anything smaller in that direction. it can't mean it has zero breadths, because then it would be nothing. Yeah, I mean, this is something, issue that mathematicians and philosophers, as Hume indicates, had been aware of for some time. He just thinks that what they say about it is a bunch of obfuscation, hiding the fact that what they're thinking is just absurd. Um, so, um, I don't know. Maybe I'd say I'm not that interested in that because I'm not sure. Like, I mean, certainly, like nowadays, of course, in geometry, wouldn't try to define such notions as point, line, and plane. Um, because what? We assume that you know intuitively what they are? I don't think that's right. Yeah. So I mean, I'm not sure. Anyway, I don't know what more to say about that. But the point. But what Hume says is that anyway, he says the definitions in mathematics are fine. In fact, they agree with me. But the demonstrations in mathematics, for example, the demonstration of this, um, somehow go wrong. So how do they go wrong? Um, well, not that there's some mistake they make at some particular step, but rather, I'm not going to show this in the book, but I'll just read it. It's from um, Book 1, Part 2, Section 4, Paragraph 8, page 34. With regard to such minute objects, they are not properly demonstrations, being built on ideas which are not exact, and maxims which are not precisely true. Um, so, in other words, Hume agrees with Berkeley about mathematics. Although maybe he puts it in a little bit nicer way. What he agrees with Berkeley that the axioms of mathematics um, are fine as far as they go, but but the mathematicians misinterpret them. They misinterpret them in such a way that they make nonsense of their own definitions. They misinterpret them as being infinitely precise, which actually is absurd because all our ideas are only finitely precise. So we have no idea of an infinitely precise standard of measurement, and therefore, if the axioms were actually said something infinitely precise, we couldn't understand them. So what the axioms say is, roughly speaking, true if you have enough points, but it's not precisely true. And so every demonstration contains a little bit of an error that the mathematicians don't realize. And I think, I mean, Hume also agrees with Berkeley that the reason the mathematicians fall into this error is, again, it's not because they've got the wrong axioms. Those are the best axioms you can get. It's because they have a misunderstanding about the nature of ideas and the possibility, the ways things can possibly exist, right? So they have a misunderstanding about metaphysical principles that are higher than the axioms of mathematics. At least as far as that goes, he agrees with Berkeley. Okay, are there questions about that? Now the question is, I kept saying I was going to come back to these arguments in more detail, but right now there's 10 minutes left. So I think I'm going to try to say something in more detail about the argument for this one. I think as far as the argument for the first point, that is that extension is finite is composed of a finite number of indivisible parts. I think the only part I really didn't I think the only thing I really didn't provide any argument at all for was the first step where Hume, like, how do we know that our ideas of extension are only composed of a finite number of indivisible parts? And Hume just argues that this is evidently true because our ideas are only finitely complex. Right? We all know that we can't think of an infinite number of things at once. And so none of our ideas could possibly have infinitely many parts. But this means the same thing. We can't think of anything infinitely big, so none of our ideas could have infinitely many parts. Okay, there's questions to raise about that, but I'm not going to get into them because I want to go back and talk about this more for a few minutes. Unless there are questions. Yes, there's a question. Earlier I said that Hume thinks darkness is like what a blind person sees. That is, it's not seeing anything. Yes, that's what he says explicitly. That if I see complete darkness, does he distinguish between when I close my eyes versus not seeing behind me? Well, when you close your eyes, you're still not seeing behind you. The difference is now you're not seeing anything. That's what he would say, I think. Right? So, what's the difference between seeing things in front of you and not seeing things behind you versus closing your eyes and seeing darkness? Yeah, I still see darkness. I mean, I don't see anything behind me, but when I close my eyes, I still see darkness. So, I'm first of all, yeah, you don't see darkness behind you. Well, I mean, what I meant by my answer, when you close your eyes, you still don't see behind you, is that how do you know the darkness you're seeing is in front of you and not behind you? I mean, there's no difference between darkness and seeing darkness in front of me and seeing darkness behind me. The difference comes between what actually seeing thing A and actually seeing thing B. But if I don't see anything, there's no telling what direction it's in. At least, again, I think that's the way Hume would look at it. I mean, what you're saying, like, I didn't emphasize this. I think I signed the section about it, though. Maybe I even didn't. I mean, Locke basically agrees with you, right? Locke says that we have as positive an idea of darkness as we have of light. And he tries to explain how that can be true even if the thing, darkness, is just the absence of light, that the idea of darkness will still be a positive thing. But Hume denies it, and it's hard to know on what grounds to argue with him about it. I mean, I agree that something about it doesn't seem right. It seems like seeing darkness is kind of like seeing something, but it's not seeing anything in particular, that's for sure. I don't know. Does that help anyway? With at least like how Hume would respond to what you're saying about seeing behind you? I mean, I put it this way: there's a difference between not seeing B because you're seeing A, and there's no room for B. That's the sense in which you don't see what's behind you, and not seeing B because. Wait, did I just switch? No, you're not seeing B because you're not seeing anything. And when you're not seeing B because you're not seeing anything, you could just as well say you're not seeing A because you're not seeing anything. You're not seeing anything, right? So you're seeing what's behind you just as well as you're seeing what's in front of you when you close your eyes. Um, um, okay, that's all I can say about it. I don't know how to make it any more plausible than that. So do I have time to say anything about what I wanted to say about it? Okay, so I mean, maybe this is not that earth-shattering, but I'm going to say it anyway, because namely, that the argument for this is, I mean, kind of indicated this already. It's based on the argument for the first part, right? That is, how do we prove that vacuum is impossible? Or in other words, how do we prove that extension is always either visible or solid? So you have to agree, first of all, that the idea of extension is an idea of something with parts. Now, that certainly agrees with the traditional philosophical definition of extension as having parts, partes extra partes, right? Like having parts outside of parts. It's a traditional definition of extension. Locke, I guess, would not agree with that as a distinction, as a definition of extension. And remember, I pointed out that although he doesn't make a big deal about it, he seems to be consistent about this, that he proves that space can be extended as far as you want. Like, right, space is infinitely large, not in the sense that we can form a whole idea of its infinity, but that we can always consider more of it. But when Locke talks about infinite divisibility, he talks about the infinite divisibility of body, not the infinite divisibility of space. Perhaps, again, because he doesn't think that the idea of a space is intrinsically the idea of something with parts. That maybe we even only get the idea that it has parts by considering it as partly filled by a body or something like that. In other words, Locke may mean by extension what Hume calls imaginary or fictitious extension. But in any case, be that as it may, so the argument starts by saying that extension, the idea of the extension is composed of parts, and therefore the idea of extension is composed of parts because it represents extension by being like it. It represents it as having parts by having parts. Okay, so what are the ideas of the parts? Or rather, what kind of ideas are the parts, right? Because you were talking about an idea. The idea of extension, it has parts that are themselves ideas. Well, I mean, of course, you can divide it up into smaller ideas of extension. This is getting blurry again, maybe. You can divide it up into smaller ideas of extension, and you can say, oh, these parts are the same as it. They also consist of parts. But you can't do that infinitely according to the first part of the system, so eventually you'll arrive at a part of extension that doesn't itself have parts. So if you ask what's the nature of this part, you can't say it's extended because that would mean it has parts. It's not extended. What is it? It can't be nothing. That is, It can't have no characteristics whatsoever, because if it were nothing, you couldn't make something by adding it to other nothings. Something must characterize it. There must be something about it that's different from nothing. And Hume says that thing that is about it that's different from nothing has to be a color or a solidity. How we know that it must be a color or solidity is an interesting question, but one that I don't have time to talk about. So I will see you on Wednesday.